Let's look at the solutions for the multiple choice questions from the March 2025 paper. Question 1.1 reads, in which one of the following combinations is the electromagnetic radiation listed in order of increasing frequency? So a question like this would require you to learn the electromagnetic spectrum. I've put in two images here, one on the right hand side and one below it. It doesn't matter which one you learn as long as you stick to it. Now, for the purpose of this question, I'm going to use this one. So if I want to go through the options and choose the one that's listed in order of increasing frequency, I have to now check according to this list. So radio waves, infrared, microwaves. Radio, infrared, micro. So you can see that obviously that has skipped. So radio, infrared, micro, that's obviously incorrect. So A is out. B goes microwaves, then radio waves. So that order is wrong. So B is also out. C goes microwaves, UV, and then infrared. This order is incorrect. So C is out. So then obviously by process of elimination, the answer would be D. And you can check it. You go radio, visible, and then UV. That order is correct. So questions like this often process of elimination, or you could just learn it. Either way, you get the correct answer. Question 1.2. If the wavelength of a sound wave is decreased, which one of the following will also decrease when the wave speed is kept constant? So, as we know, there are two formulas that we can use to calculate the speed of a wave. The first formula is V equals F times lambda. And the second one is V equals lambda divided by period. Now, if they decrease the wavelength, right? So let's look at the first formula. If we decrease the wavelength and V is constant, it means that the frequency must increase. So obviously that's not going to work because we want to know which will decrease. Now you can think of this, if this doesn't make too much of sense to you, you could think of it in the sense of an equation using numbers. So for example, you could say 16 equals let's say 2 times 8, right? If I decrease this number, say I make that number 4, and the answer must still remain 16, what must happen to this number? That number must increase. From 2, we need to go to 4. So we can see numerically how it works. So let's start eliminating. So amplitude is out because amplitude obviously is not one of the variables in an equation. Frequency is out. We just saw why frequency is out. And then pitch will also be out because pitch and frequency are related. And then again, by process of elimination, we get period. So period is the answer. And you could test it using numbers like I did, and you see the answer. Question 1.3. Which graph represents the relationship between frequency and speed of a photon? So important here, speed of a photon of light in a vacuum. Now, we know that light travels, or photons in light travel at a constant speed, c, which is 3 times 10 to the power 8 meters per second. And this is for all wavelengths of the electromagnetic, for everything in the electromagnetic spectrum. So since this is a constant value, it will not change if the frequency changes. Okay, so we can see it here in this diagram. All of these things that's in the EM spectrum, radio, microwave, infrared, UV, X-ray, gamma, they all move at a constant speed, 3 times 10 to the power 8. But they all have different frequencies. So The answer to this would be B, that the speed is unchanged. Okay, the speed is unchanged. Now let's look at this last question. 1.4. The wave below is traveling at a speed of v meters per second. The distance between point P and Q on the wave pattern is x meters. Which one of the following is the frequency of the wave? So we can use the formula v equals f multiplied by lambda. Okay, now the speed is v, it's given to us, so v equals f, but now in terms of lambda, they've given us some distance between P and Q, and we need to understand what that is. So P and Q is actually two waves, because from P to this point is one wave, and from this point to Q is another wave. So from P to Q is actually two waves, and lambda asks us what is the length of one wave. So that's obviously going to be half of x. So half of x. And if you want to solve for frequency, we need to divide. So we divide both sides by half x. So v divided by half x equals frequency. Now, we need to check which one is the option here. So b will be out. C looks similar, but there's a 2 in the denominator. We have half in the denominator, so C is out. D is out. That means we're left with A. But how is that the case? So if you're dividing by a fraction, in this case, if you're dividing by half is the same as multiplying by 2. So this is the same as saying 2 times v over x, which is 2v over x. So the answer to that question, A.